1.6 is about inverses. So let's do just a little review. So an inverse is whenever you exchange x for y. So we have numerically, we're going to change x and y. So we're reversing them. So the way that you will see it written is the first function is f of x, but then the inverse is f negative 1x. That's how you distinguish that it is the inverse. Whenever you have a graph, so let's say here's your coordinate grid. So if this is your function, I guess it changes all of it. I was trying to change it separately. Then whenever we do the inverse, it's going to exchange the x for the y. So it is going to, if we look at our graph, let's say f of x is x squared, then our functions x, y, let's make the table starting with -2, -2, -1, 0, 1, and 2. When we square it, we're going to have this. So that's our 0, 0, our 1, 1, our 2, 4. -1, 1, -2, 4. So then if I do the inverse, so this would be f of -1x. Let's make our table. I'm going to interchange x and y. So I'll have 4, 1, 0, 1, 4. And then the y's will be whatever the x's were on my original. Hold on, let me back it up. It should be 1 and 2. There we go. So whenever I graph that, I have 4, 1, 2, 3, 4, -2, 1, -1, 0, 0, 1, 1, and then what is the next one? 4, 2. So it's going to look like this. So they're interchanged, and what we actually have is that they are reflection across y equals x. So graphically, which is what we just talked about, symmetry of f of x and f -1x along y equals x. Analytically, composition function and identity function. So we will look at that more as we go through. Okay, so let's look at the horizontal line test. So we did the vertical line test whenever we talked about is it a function. So now we're doing the horizontal line test whenever we're figuring out if the inverse is a function. So if every horizontal line intersects a graph of a function at most 1, then the inverse graph is also a function. It passes the vertical line test. One-to-one function, a function that passes the horizontal line test. So if it's already a function, it passes the vertical line test and the horizontal line test. So let's look at algebraically how to determine the function, the inverse function. So let's go ahead and look at this. I'm going to rewrite this 1/5 x as x over 5. So if we go ahead and plug in y equals x over 5, to find the inverse, I'm going to switch the x and the y. So x equals y over 5. So if I want to solve it for y, so now solve for y. So what we did here was switch x and y. So now we want to solve for y, so I'm going to multiply by 5 on both sides. And I get that crosses out, y equals 5x. So the way we are going to write it is the inverse function. Let me write it so you can see it a little better. Is 5x. So these are inverse functions. So what we want to see is it, we want to verify this right here. So what we're going to do is the composition of the functions. So let me get a different color here. So we want to do f negative 1 actually, let me back that up. Let's do f of the inverse function first and see what that gives us. So the original function is x over 5. So what I'm going to do is I'm going to plug in this 5x, so f of 5x, into the original function. So the original function is 1 over, or it's x over 5 right here. So I'm going to plug in 5x over 5, which when we simplify that, we get x. So we checked this one. Now we've got to check the other one. So now we're going to do the inverse function with f of x in it. So that's really f of negative 1 and then x over 5. We're going to plug in x over 5. So here's our original function. So it's 5, and we're going to plug in x over 5. So whenever you multiply those, you actually get x. So we just verified both of those. So we just proved that they are inverses. That's how we proved it. So let's look at the next one. Show algebraically that f and g are inverses. So all we're going to do is just like we did the last one. So I'm going to do f of g of x. So the f function is x cubed, but the g function is this. So that means I'm going to put in this into the function. And whenever you do that, whenever you take the cube root, but you cube it, those are inverses of each other. So it does equal x. So we just proved the first one. So now let's do the other one. Now we're going to do g of f of x. So g of the cube root of x. So I'm going to plug in, oh, no, I did the opposite one. Let's do g of f of x. There we go. So I have the cube root, then put in the x to the cubed. Well, again, those cancel each other because they're inverses. So it equals x, so they are inverses of each other. Okay, so remember with function composition, it also looks like the f of g, right, of x, and then do g of f of x. So we just did the composition. So these are the same thing, just a different way of notating it. So let's do the first one. So this is going to be square root of, so in place of x, I'm going to plug in this, x squared plus 4 minus 4. Extend your square root. We don't need to do anything with parentheses. It would actually go away. So that becomes 0. So then we just have x squared. Square root of x squared equals x. So we're good on that one. So let's go to the other one. So then we do, I'm going to plug this in for the x now. So square root of x minus 4 squared plus 4. So whenever you square root and squared, those are inverses of each other. So that is x minus 4 plus 4, which equals x. So that proves that they are inverses of each other. Okay, now let's look at one-to-one. A function f is one-to-one when for a and b in its domain, f of a equals f of b implies that a equals b. So let's go ahead and just write this as y equals square root of x plus 1. And we are going to find the inverse, so we can look at that. So that's going to be x equals square root of y plus 1. We want to solve it for y. So whatever I do to one side, I have to do to the other. So I'm going to subtract 1 in the beginning. So I get x minus 1 equals square root of y. To get rid of a square root, I'm going to square it. So, and I'm also going to flip it around. So it's y equals x minus 1 squared. Which means x minus 1 times x minus 1. Whenever I do that, you can do your FOIL, you can do the box method. So it's y equals x squared minus 2x plus 1. So our inverse function is f negative 1x equals x squared minus 2x plus 1. So it says determine algebraically whether the function is one-to-one. Verify graphically using the horizontal test. So we have our functions. So here is our original, and here is our inverse function. So what we need to do is do our graph. So what I'm going to do is I'm going to put it into the calculator. So TI. No, it's not TI, it's just calculate. So I'm going to go to y equals. I'm going to clear out what's in here. And I'm going to put in the original square root of x plus 1. Okay, so if I look at that, it passes the vertical line test. We know it's a function. And it also passes the horizontal line test, because if I go sideways with it, do horizontal lines, then it will pass the horizontal line test as well. So I want to write that it looks like this. So horizontal line test, check. So we're good. Okay, let's look at the next one. If we graph this, let's go to my calculate. So when you go back to that, clear it out. So it's x raised to the 4th plus 2x squared. Oh, I gotta back that up. Let's try this again. Minus 6. Okay, hey graph. So it looks like that. So it passes the vertical line test, but look at the horizontal line test. If I do horizontal lines, let's look at what that would look like. If we do this, this is our original function. If I do horizontal lines, see how it passes twice. So this is not one-to-one. We could find the inverse, but it's not one-to-one. Okay, let's go to the last one. Okay, so this is like y equals 3x plus 4 over 5. So we want to look at what that looks like on a graph. So I'm going to go back to my calculator, go to y equals, clear that. I'm going to put in my fraction. And so I have 3x plus 4 over 5. hit graph. Oh, it's just a vertical. I mean, it's just a straight line. So this is linear. So if I were to draw this on my graph, let's see, let's double check. Okay, it looks like this. So if I do horizontal lines, we're good. It only passes one time. So it is 1 to 1. So now we're going to go ahead and find the inverse function. So I'm going to do x equals 3y plus 4 over 5. So we're going to solve. So I'm going to multiply times 5 on both sides. So I have 5x equals 3y plus 4. Subtract 4. 5x minus 4 equals 3y. Divide by 3 all the way through. So then my inverse function is f negative 1x equals 5x minus 4 over 3. We will finish the rest of this in class.